Welcome back to Math for Technology. In this video we are going to start Chapter 5. Chapter 5 is starting with the trigonometry, and we're going to start with basic right triangle trigonometry. In Section 1 we are going to focus on angles, angle measure, and the trig functions. We'll learn the first 6 trig functions. The very first part of the assignment I'm not going to go over again. That is simply converting between radians and degrees, which we did in Chapter 3. What we have here is an angle. This angle is given to us where the angle begins on the positive x-axis and it ends somewhere else within the circle. It is rotating, or its vertex is at the origin. When an angle is in this position, it's called standard position. So again, standard position simply means it starts on the positive x-axis and its vertex is on the origin. The place where it starts, or the side on the positive x-axis, is the initial side. Where it stops is the terminal side. Which makes sense. Terminal is where things end. Now this one is ending in quadrant 1. It could end up in quadrant 2. Remember your quadrants from previous math, not just my class. And then it can end up in quadrant 4 down here. This equation is rotating up. It is positive this angle is positive because it's rotating up. If the angle rotates down, it's negative. For example, I have two angles here. Both of them are in standard position because they both start their initial side at the positive x-axis. The one here on the left is rotating up, so that's a positive 135. Its terminal side is in quadrant 2. The one on the right is rotating down, or clockwise. It's clockwise, so that is a negative angle. Other things that we can do with this besides find trig function is there are many angles whose terminal side ends where this one does on the left here. Not only could I have rotated up, I would end up in the same position if I actually rotated down. So if you think of the hands on a clock, and instead of going counterclockwise it went clockwise, it would have still ended up in that position. Now what is that angle though that is created with my blue line there, my blue arc? Well, together they make a full circle, so they make 360. So to find this angle on the negative side, we take 360 and we subtract 135. 360 minus 135, 360, 260, 230, 225. Now, because it started going clockwise, it is negative 225. Negative 225 and positive 135 are called coterminal angles. They're coterminal because they end at the same terminal side. That's why they're co. Now, those aren't the only two. There's many, many more. We don't have to stop at one circle. So another positive one would be to stay here, go up, go all the way around, come back, and still end up at that terminal side. My new one in the green there, which for some reason disappeared, is 135 plus 360. So the green angle would be 495. It's another coterminal angle to 135. We can do the same going on the downward or clockwise position. We can go 1, that's 360. We can go again, so that's another negative 225. So we can go negative 225. Now I'm going to minus 360 because I'm moving in the clockwise direction. Negative 225 minus 360 is negative 585. So that's another coterminal angle. And I could do this over and over and over again. The same thing would occur on the negative 60. If I wanted to know one of its coterminal angles, maybe the positive, instead of going down 60, what would it be if I went up? Together they make 360, so 360 minus 60 means it has a coterminal positive angle of 300. And again, I could do multiple circles. So let's do some examples real quick and then we'll keep moving. What would be, let's see, first it wants me to draw an angle of 315 degrees. Well, 315, it's positive, so I need to move up. I'm starting on the positive x-axis. If I'm moving in a positive direction, now, this is 90, this is 180, this is 270, full circle makes this. Now if I stay there and I don't ever move, it's 0. But if I go all the way around, it's 360. So I know my angle, 315, is somewhere between 270 and 360, and in fact it's halfway between, so it's going to end approximately here. So that red arrow is my angle of 315. So I drew it in standard position because I started at the positive x-axis. Being positive, I moved up. I drew an arrow to indicate rotation. We need to find two other angles, a positive and a negative, that are coterminal. So remember that just rotates 360 degrees. To find a positive coterminal angle, I'm simply going to take the 315 and I'm going to add 360. 315 plus 360 is 675. I can do it again if they asked for more. A negative coterminal angle would be take your angle and instead of adding, subtract 360. 315 minus 360 is a negative 45. So these are two coterminal angles to 315, and again there are an infinite amount. You just keep adding 360 or subtracting 360. So far we've just worked with the angles, and we can work with them a little bit more. The angles don't have to end up between in any one of those quadrants, in quadrant 1, 2, 3, or 4. Sometimes our angles will actually end up on the quadrant. And if it ends up on a quadrant, on one of the axes, then it is called a quadrantal angle. We are still starting in standard position. So if an angle starts on the positive x-axis, if it stops on the positive y, then that is a 90 degree. So it's rotated a quarter of the turn. If it ends on the negative x, that's 180 degrees. If it ends on the negative y, that's negative 270. And if it comes a full circle and all the way back around, then that's 360. So if it ends on any of the axes, that's a quadrantal angle. Now what we're going to do is we want to be able to find ratios between the side lengths, because what's going to happen is we're going to be giving points. So say I was given the point, I don't know, let's just pick a point. There's a point. And I would like to set up the ratios of how this relates to its position in the coordinate system. So let's think about what I know. I know that it is 1, 2, 3, 4 units down from the negative x-axis. I also know that it is 1, 2, 3, 4, 5 units to the left of the origin. I can also figure out, because we know some information about right triangles, the distance it is from the origin to that exact point. So if we've created a right triangle and I know 2 out of 3 sides, I can find this longest side, or the hypotenuse, by doing the Pythagorean theorem. In our equations and in our ratios, this is our x, which makes sense because it's on the x-axis. This is going down, so this would be my y. This, because it's the distance from the origin to the outside, is called r, because many times when we're dealing with trigonometry we use what's called a unit circle, and so all the points that are that same distance from the origin, r, have similar ratios as we move around. So let's go ahead and do the Pythagorean theorem real quick and figure out what r is. So the Pythagorean theorem is a squared plus b squared equals c squared. Doesn't matter who a and b are. I'll just do negative 4 squared plus negative 5 squared equals c squared. This is a b, not a 6. 16 plus 25. 16 plus 25 is 41. So C is the square root of 41. And for right now, we're going to leave all of our radicals in radical form. Okay, so we learned a little bit about quadrantal angles. We learned a little bit about how we can relate any point to where its position is in the graph. And the whole idea behind this relation is so that we can do trigonometry. So in our trigonometry here, we have this little table. We have 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. So let's write them out. This is sine, cosine, tangent, cosecant, secant, and cotangent. So the typed part are their abbreviations, and that's what you'll see most of the time. I wrote in what their names are. So, and I didn't look up to see who got to decide who named these, but they did decide that these were the ratios. So when I want to know what the relationship is to the y-axis to the radius of a point on a graph, they chose to make that relationship or that ratio the sine. Cosine is the relationship between x and r. Tangent is y and x. Now if you ever want to have those in their reciprocal form, we would then use cosecant, secant, and cotangent. So based on the figure that I have above, this one here that we worked with, we have an x of -5, a y of -4, and we ended up with an r of square root of 41. So let's write those down. I had an x of -5, a y of -4, and an r of square root of 41. So what we can do then is see what is the relationship between those sides at that point. My thing's not scrolling. So what is the relationship of these sides at this exact point? Well, that relationship is, if we're looking for the sine relationship, it's y over r. Y is -4. R is square root of 41. That's the relationship. Cosine is x over that, so it's -5 over square root of 41. Tangent is y over x, so it's -4 over -5. We do want to go ahead and simplify those negatives, so it's just going to be 4/5. The bottom three are the reciprocals, so cosecant is the reciprocal of sine, so just take your sine relationship and flip it upside down. So it's the square root of 41 over -4. Secant is the reciprocal of cosine, so I'm going to flip this one upside down. It's square root of 41 over -5. And cotangent is the reciprocal of tangent, so I'm going to flip 4/5 upside down and I get 5/4. Okay, so let's do that with just a point. Now you can actually graph it if you want, but what we did up above is we took our x-coordinate and our y-coordinate and we just worked with the Pythagorean theorem. So we could just do that. -5 squared plus -2 squared equals r squared. 25 plus 4, 29. So r is the square root of 29. So I know x is -5, y is -2, r is square root of 29. So I can do my functions. So I have sine of theta. And just to back up for a second, so theta is the symbol that is just used for the angle that is created. So we did talk about that a little bit before. This is theta. We used that same symbol when we worked with circles in the geometry chapter. So theta is the angle created by the terminal side and the x-axis. So sine, if we look at our chart, is y over r. My y-coordinate is -2. My r is square root of 29. My cosine is x over r. x is negative 5 over r, which is square root of 29. My tangent is y over x. Y is negative 2. X is negative 5. I would make that 2/5. Now when I go to do the other three, if I do them in the right order, I just have to flip these over. So sine is the reciprocal of cosecant. So I'm just going to flip that over. I get square root of 29 over negative 2. Cosine I'm going to flip over into sine. I just wrote that wrong. Cosine I'm going to flip over into secant. Make sure I do the right ratios. Flip that over, I get square root of 29 over negative 5. Tangent is the reciprocal of cotangent. So I flip over 2/5 into 5/2. Now that same process still works even if we're doing a quadrantal angle. So I still have an x, I still have a y. Now if you said, well, how do I know that's a quadrantal angle? Think about where negative 5, 0 is. Negative 5 goes this direction and it says it's not moving up or down. So it's on the negative x-axis. Remember, if any of them are on the axes, either y-axis or x-axis, it's a quadrantal angle. So this is where that point is. So I have an x and a y. I still would do the process of the Pythagorean theorem. Hopefully what you will notice as we do this, negative 5 squared is 25. Equals r squared. 25 plus 0 is 25. R is going to be 5. And so what happens is the distance from the, remember r is the distance from the origin to your point. Well, if you're only moving in either a horizontal direction or vertical direction, your r is going to be the absolute value of whatever way that you're moving. So our r, in this case, is 5. If it was moving up, our r would be the absolute value of that number, or down, absolute value, or to the right, absolute value. So I still go through the same process. Sine is y over r, so that's 0 over 5, which is 0. Cosine is x over r, so negative 5 over 5, which is negative 1. Tangent is y over x, so 0 over negative 5, which is 0. Okay, now I'm going to do the reciprocals. Sine is cosecant. Cosecant means we're going to flip this upside down. If you flip 0 over 5 upside down, you get 5 over 0, which is undefined. Flip cosine upside down, we get secant. Negative 1 flipped upside down is still negative 1. Do cotangent by flipping 0 over negative 5. We have a similar scenario as we did to cosecant, so we end up with undefined. So 0 and undefined are reciprocals of each other. Okay, we have one more we're going to work through on this group. There's a point P on the terminal side of an angle theta in standard position. Determine the 6 trig functions of theta if x equals 6, r equals 10, and y is greater than 0. So let's visually see what's occurring here. So x is 6, 1, 2, 3, 4, 5, 6. R is 10, so we know it's 10 units away from the origin, and y is greater than 0. Y being greater than 0 means it has to go up. So what we know, oops, let's make that a straight line. This is 6, this is 10. Right now we don't know what the y value is, we just know it went up because it was greater than 0. So we're going to do the Pythagorean theorem, we're just going to do it solving for y this time. So we have 6 squared plus y squared equals 10 squared. 36 plus y squared equals 100. Y squared equals 64, so y is 8. Now we can go ahead and do the 6 trig functions. Sine is y over r, so that's 8 over 10, which which is 4/5. Cosine is x over r, or 6/10, which is 3/5. Tangent is y over x, so it's 8/6, or 4/3. Go ahead and do the reciprocals. Cosecant would be 5/4. Secant would be 5/3. And cotangent would be 3/4. So even if they don't tell you everything about the x and the y, but they give you an approximation, you can figure out the parts. If you have any questions, please let me know. Have a good day.